Hi, this is Bits and Pieces, the official podcast of Component Supply. I'm Kristin, and today Mark is our cameraman, and instead we have Bob Hoffman from Royal Master Grinders here today. Thanks, Bob, for being here.
Thanks for having me, Kristin. I'm happy to be here at Component Supply.
So we're excited because, Royal Master Grinders has been a huge resource for Component Supply over the years, and so today we want to talk about you, about the capabilities of Royal Masters and what implications there are for engineers in the medical device space. But first, can you tell us your story, how you got started with Royal Master?
Sure. It was 1987. There was no internet. There was no LinkedIn. I was a recent college graduate looking for a job, saw an ad in the paper at Royal Master Grinders. And when I started at Royal Master, I worked in several different departments to learn the company and learn the machines.
That's awesome. So you've been with Royal Master for a long time.
Yes.
So centerless grinding has benefits for lots of different industries and capabilities. We are a resource for researchers and product designers in multiple industries, but for today, do you want to focus primarily on medical device space, primarily in mandrel and guidewire production. So we're trying to be a resource for researchers and product designers that are in any phase of their career, whether they're just starting out fresh out of college like you were when you started at Royal Master, or have been in the industry for 30 years. So from your experience, because you do have so much of it, you've seen lots of different things, you've worked in different areas of your organization, what are the main reasons that an engineer would use Royal Master grinding technology to produce a mandrel or a guidewire?
Okay, good question. Centerless grinding mandrels and guidewires is a very efficient way to remove material, hold a close diameter tolerance, and maintain a good surface finish, and sometimes grind a profile into a rod or a tube. Keep in mind that the small diameter and long lengths make these products a perfect fit for grinding, not turning.
Can you explain the difference?
Sure. With turning, you'll typically extend the part outside of a collet or a chuck or a guide bushing, and a tool will push on the part, removing material. That makes it vulnerable to deflection.
Okay.
With centerless grinding, we support the back of the grind with either a regulating wheel or, in the case of the Gen X machine, a backer.
Okay. Okay, so we have several Royal Master machines on the floor. We have some that are very manual, and we've moved to, you mentioned the Gen X, we moved to more automated equipment. Royal Master has done this, right? You've gone from these very manual machines to more automation. What are some of the changes in the industry or changes in your customers' demands that led to more automation?
Well, when we started, we were involved in through-feed grinding, a single diameter part, or in-feed grinding, a multiple diameter part.
Right.
And we would through-feed grind a wire and shape the wheel to have dress a profile into it. So we would through feed it up to a certain point and then open the wheels. That would leave a taper where the wheels last touched the part, and that was good for grinding a single taper on a part that the taper length was less than the wheels were wide.
Right.
So if you had multiple taper grinding requirements, you would have multiple setups.
Yes.
And do op 1, followed by op 2, etc.
Right.
And you could do multiple tapers, but it was time consuming and many setups in between.
Right.
In 1987, we developed with our CNC ram bed the ability to interpolate that profile, which means coordinate the axis of the ram movement and the wire traveling through the wheels. And as the wire traveled through the wheels, at a certain point we would back the ram up and generate a taper, and then hold that position, generate the second diameter, etc.
Okay.
So with that, we evolved into CNC guide wire multiple profiles that could be longer than the wheels are wide.
Right. Yeah, so great advancement. We take advantage of those for sure. We've got this latest machine that really can do more than just grinding and tapers. There's a 4th axis grinding wheel that can be installed. Can you kind of go over that machine and its capabilities and maybe what applications would benefit from it?
Sure. The Gen X machine is a unique departure from centerless grinding. It does not have a regulating wheel where the grinding wheel and the regulating wheel and the part is supported on a work rest blade. We take the regulating wheel away. We have a ram bed that moves just like the conventional centerless, but it has a carbide backer. And the carbide backer supports the position of the wire, and it controls the gap between the back of the carbide backer and the front of the grinding wheel.
Okay.
So that's what controls the diameter, the ram movement, and the regulating wheel not being there. We're rotating the part by holding it in a collet, which is in a workhead, which is on a linear actuator.
Okay.
So as the linear actuator moves, it moves the wire through the wheels. As the regulating wheel, as the ram retracts, it controls the gap or the diameter of the wire. So that's the Gen X, the principle of the Gen X grinder.
Yeah.
We add a fourth axis, which is an addition to the standard grinding wheel. The fourth axis moves on its own linear actuator, and it could be removed for clearance or moved into the part to create unique shapes. Very intricate shapes or flats, or we could rotate the wire as it travels through to create a helix or grind a thread like on a dental file.
Yeah.
And we can grind flats by putting the wire stationary and then move it through. And these flats are sometimes called pocket wires on a guide wire.
Okay. Yeah, so for those of you who are invested at all in component supply social media, you'll see occasionally a post or a reference in a newsletter to BLT. We just think it's funny. Bevel, Lancet, Trocar. That's how you can quickly remember that component supply has these capabilities because we have this machine in-house. But there are so many different capabilities that you have options, right? So when an engineer is determining which of these many capabilities that a Royal Master grinder offers, and they're designing a device, they're making a mandrel or a guide wire for their device. What should some of their top considerations be to determine which capabilities they might benefit from in their design?
Very interesting question. So centerless grinding has traditionally been a finishing operation. It is in the abrasive machining category.
Okay.
Typically, a part is turned to create a shape and then centerless ground to hold a tolerance and a surface finish. You want to study the material, the stock removal, the tolerances, and the profiles of your part to make the choice of what machine features will provide benefits. As a design engineer, you want to be careful to design a product with manufacturing capabilities in mind. And this is very important. You want to avoid features or tolerances that are not critical to the function of your device, but would create a high cost to manufacture.
Sure. And we see this with more than just our tapers, whether it's, we will have a wire application that requires a bending, and they will call out every single radius or angle. And we always go back and say, are all of these actually critical? Because if it is, and are these tolerances really, do you really need it this tight? Because a lot of times they're kind of putting their best case scenario. We kind of joke they have it blown up on a big screen. It doesn't look that hard, but the part's actually quite small. Right. So if you are taking serious consideration for all of those specifications, it becomes a very expensive part because of the time that goes into it.
Yeah. Study the function of the part.
Right.
And is it necessary for the function of the part?
Right.
Or is it just showing that you can carry a decimal out to the fifth place here?
Right, exactly. What is actually critical? I think it's such an important question, especially for engineers starting out. It's exciting that you're smart. You have all this information. You can actually create a design that calls out all of these specs very accurate. But when you get to the practical side of actually making the part, it's either impossible with all the other characteristics of the material, or it's just going to become time-consuming and expensive.
What you described is what you do. You study the print, and it's time to have a conversation.
Yeah.
Because maybe if we change this dimension or if we change that tolerance, we could make the part rather than no quote, or we could make the part faster and therefore cheaper.
Yes. It's such a good point. It's every engineer's challenge, I think, is how to make a design that's cost effective and efficient. So what limitations, we talked about some of these already, any specific tolerances they should be aware of, or specifications that they really must include or omit from their design to make it manufacturable.
Okay, so the limitations to centerless grinding include how much stock can be removed per pass, how many diameters are to be ground, and how close of a tolerance needs to be held. These part characteristics are what we look at to determine what type of grind will be best suited to create the grind result to print.
Right.
So you want to look at the diameter tolerances, and a 2/10 diameter tolerance is achievable. Okay. You want to look at the linear tolerances, and generally a 5 thou linear tolerance is achievable. It's a close tolerance, but it's achievable.
Okay.
When there's a taper transition from one diameter to the next, the flatter that taper, the harder it is to identify by gauging where that taper actually started and where it actually ended.
Right.
So on those flatter tapers, you must have a more open tolerance, or you'll get no quotes back.
Right. Or you'll have component supply say, can you handle this tolerance? We always try to offer a reasonable suggestion based on whatever experiences we have and what training we've received. But yeah, sometimes it's just a no quote because they have not been able to loosen that spec for some reason. So they have to go back to the drawing board until they can, realize what they can handle. Royal Master, your company is at several trade shows. We see you at MD&M, and there's always something new to see and to learn. I'm always excited for you to give me a demo of the latest machine, but you're at other shows too.
Yes.
What other shows?
Yes. So a big show for us is the IMTS show, which is every even-numbered year in Chicago.
Okay.
So that show is every 2 years. The MD&M West show is every year.
Yeah.
And we use each of them to showcase new developments.
Yes.
And we schedule our engineering and our new product developments for those shows because it's a great way to present it. We present it at the show, of course, but we also then introduce it by way of the internet and our website.
Yeah, and your booth is always busy. There's always so much to see, and because of this reason, there's so many capabilities that are available. Engineers are going to have to narrow down the scope of what they need because it's easy to get excited about all the possibilities there. But we've so benefited from the relationship with Royal Master. The machines are amazing. The customer support you offer. I know you have a great team at home taking care of customers, and you speak a little bit to that with the size of Royal Master that you're able to service customers so well.
Yeah, sure. So we're family owned and operated and have been so since 1950. So we've been in business for 75 years.
Wow.
And the owner, John Memelar, is very much involved in every aspect day to day. He thrives by working with the company, and every employee goes out of their way, wears multiple hats, and we all achieve a great goal, and that is to be available, approachable, and to support the equipment that's out there and work with people who are developing new processes.
Yeah, it's a gift to have you in the industry. So if you are looking for any kind of grinding capability, centerless grinding, you need tip grinds, tapers, component supply has these capabilities. We have great support in Royal Master for when something comes our way that we haven't seen before. We look forward to those conversations. You can hop on the website, give us a call, chat online, send us an email. So many ways to get in touch with us and send your drawings. So I hope you do. Bob, thank you so much for being here.
Thank you, Kristin.
Appreciate having you. And now go change the world.